question number 1, and it's confirmed by Andrea Mercado, Daniela Montoya, and Priscila Montes.
Hi, my name is Andrea Mercado and I'm gonna explain you our physics and calculus problem. Alex's baseball helmet is thrown upward with an initial velocity of 19 feet per second for a 700 feet high building. Please do not ask why. The first instruction is to write position equation from the baseball helmet. Next, find the equation of the velocity for the baseball helmet using the derivative definition with limits. Then explain the meaning of the obtained velocity. Calculate the value of the maximum position of the baseball helmet. Calculate the value of the impact velocity for the baseball helmet. Calculate the value of the acceleration for the baseball helmet after 2 seconds and decide if the baseball helmet can still be in one piece after hitting the ground.
This is our variables. The g is the gravity, that it's minus 32.2. The initial position, it's 700 feet. The initial velocity, it's 90 feet per second. And we need to find out which is the initial position and initial velocity.
Hi, my name is Andrea and I'm going to explain you the first instruction of our problem. First of all, we need to know that this is our mathematical model. Who is going to bring us the first answer of the letter A that says that we need to find out the position equation. Because we substitute our variables to here. We have the initial velocity, the initial position, the gravity, and later on we're going to explain that we're going to use this value to get the acceleration. So we need to find out which is the velocity. Our formula to get the second instruction of our problem is going to be this formula.
Now I'm going to explain you the process to get the answer of the equation of the velocity. First, we substitute all values in our last equation, and we get all these values, and then we get similar values, and we eliminate them because they have the same. Then we substitute the value of this h to 0, and we get minus 32.2t plus 90. And then we get here our final result, which is the limit of h approaching to 0 of this equation is equal to 32.2 times plus 90 feet per second.
And our next instruction is to calculate the value for letter C is that the velocity changes with respect to time, and the velocity is our independent variable. Velocity increases and decreases proportionally to time. Value of the maximum position of the baseball helmet. So we're gonna use this formula. So we know that the final velocity is 0 feet. The initial velocity is 90 feet per second. The gravity is minus 32.2. The initial position is 700, and we need to find out which is the So we get that
Instruction says to calculate the value of the impact velocity for the baseball helmet.
7-8 feet.
First, we get the time when the helmet hits the ground, making our velocity with respect to time equal to 0. And we got that the helmet hits the ground after 2.79 seconds. Then we substitute the time in our formula and we got that the velocity when hitting the ground is 179.8 feet per second.
We need to calculate the value of the acceleration of the helmet after 2 seconds. In order to know which is the equation of acceleration, we need to derive our velocity with respect to time. So we get the acceleration with respect to time. So this is going to be our formula. And then we're going to substitute the value of t with 2 seconds. And finally, we get that the acceleration after 2 seconds is going to be this one, minus 1.39 feet per second squared.
This graph shows the position of the helmet through the time. And this is our flowchart. This is our procedure. This is all our progress to the result.
Its impact, the helmet will stay complete.
Send me